So in doing this problem here, we need to create a piecewise function that has three pieces, two with different positive gradients and one with a negative gradient. It's got to be continuous, so it's all got to connect, and this is the part that's tricky. Okay, so I need to have its invertible, and the domain is restricted to bigger than 3, but not convertible, and this is the domain for smaller values for k smaller than 3. So within my function at 3, or bigger, it's invertible. Invertible means that it is always increasing or always decreasing. It passes, we know we have our vertical line test for functions. Well, invertible is about the passing also the horizontal line test. And so this particular function, if I have this, is not invertible. So in order to make this work, I'm going to have some kind of function. I need a positive graph, a negative graph, and then a different positive slope. Okay? And so at this point, I've got two different positive gradients and a negative gradient, and it's continuous. And so now I have to think about this invertible part. So if I make x be bigger than or equal to 3, if I make this value here 3, then if I look at the domain specifically, that is x is bigger than or equal to 3, I have just this part of the function, so I know that that is invertible. It passes, this part of the function passes the horizontal line test. Okay, if k is smaller than 3, so if I have some value, like some value here is k, right, then I know it fails the horizontal line test and it is not invertible. So now it's just a matter of defining the function. So I can call this f of x, and really I need this part to be bigger than or equal to 3. And let's just say if I continue this over, this is 1/3 x. So at 1/3 x, I know this has a y value of 1. If I make this 2, and if I make this height here 2 as well, then I know it's going down 1 and over 1, down 2, up 2, so 4. I think the function negative x plus 4 should work to be this one here. This is the point 2, 2, and as long as it's not 1/3, I could do positive x plus 1. Oh, positive x plus 1 will, and granted it's going to go this point, and then I have this scenario here where this is for x that is less than or equal to 2. This function is going to be from 2 less than x less than 3, and now it is continuous. So there's lots of different possibilities for these, but the key is that continuous, so it connects, and that at 3 is where it starts to break off as such.